Hello there, ladies and gentlemen, boys and girls. This is Mr. Dickin from A2TS here with your video lesson on Unit 6, Day 15, Graphing Sine and Cosine Graphs, Part 2, the sequel. Just as a quick little recap, things that we've previously discussed. Anytime you have a number being multiplied out front of a sine or cosine value, that is going to control the amplitude. How high up off the midline or how low down from the midline does your graph go? So all the peaks and valleys, how far away from the midline are they? Amplitude is always written as a positive number, even if your A value up here is negative. That negative just controls a reflection if there is one. The B value, the number that is attached to the X, that's going to help us discover the period of the function. How far does it travel before we repeat? The formula again is 2 pi over B. So if our B value is, let's say, 3, our period would be 2 pi over 3. Now the new one is going to be this D value here. And you'll notice I have a plus or minus because with the D value, that variable, it could be positive, could be negative. That's going to control vertical shifts of the graph. That's going to move our graph up or down, depending if it's positive or negative. When we need to write the equation of the midline, it's going to be a horizontal midline, so y equals, we're just going to take whatever that D value is. So if it was plus, it'll be a positive here. If it was a minus some number, it would be y equals negative, whatever that D value is. Now, just as a recap yesterday, if you ever have a negative A value, you're going to have a reflected graph, meaning your curve just flips upside down. That's it. If at this point you need to pause this screen, please go ahead and do so to make sure you have all this stuff written down. Now let's take a gander at an example. So we're going to use the function 4 cosine 2x plus 3. We need to identify the amplitude, period, and any transformations for this function. Well, first off, I'm seeing a 4 out front. That's my A value. This 2 right here, that's my B value. That'll help me find the period of the function. And lastly, this plus 3, that is a vertical shift. So my amplitude is going to be 4. My period is going to be pi. Now the way that I find that is I take 2 pi divided by b. Well, 2 pi divided by 2 is just 1 pi, so pi. That indicates that my interval, so each increment that I'm counting up by in the x-axis, is going to be pi over 4. To figure out the interval, I take the period, whatever I get here, and I divide that by 4. Lastly, my shift, my translation, is up 3. So this thing right here, this D value, this plus 3, tells me that my whole graph is going to shift vertically 3 units. So let's take a gander, if you will, at the skeleton of the graph. First thing I did is I plotted my midline, y equals 3. I find that from the D value of the initial function, which is my vertical shift. So right here in purple or pink, magenta, mauve, I don't know what color you'd call that, whatever that is my midline. Then from there, I use my amplitude, in this case 4, and I'm going to count up 4 units. So 3 plus 4 is 7. And I'll count down 4 units. 3 minus 4, that puts me at negative 1. My whole function will be oscillating back and forth between those two blue lines, and it will be bouncing back and forth across that middle line. Next up, I labeled my x-axis. For this class, we're always going to start at 0 on the x-axis. We're not really going to shift them left and right, although that is possible, so be ready for that next year in pre-calc. We know that it's got a period of pi, so if it starts at 0, that means it's going to end over here at pi. Then I put my increments in the middle. So the intervals that I'm counting up by are pi over 4. So here this is 1 pi over 4, then 2 pi over 4, which simplifies to pi halves, pi over 2, then 3 pi over 4, and then this would be 4 pi over 4. Well, that's just 1 pi. So now I have my entire framework laid out. Hard part's done. All that's left is to plot some points and draw in the shape of a cosine. All right, well, I know that a cosine, let's use a fun pen. I know that a cosine starts at 0, 1. Usually it starts up at the top line. We didn't flip it at all. So for this one, it's going to start up there on that top boundary line. Wherever it starts, that's also where it ends. So I can put a dot over there as well. Then in between each interval is going to tell me where to put a marking. So I'm starting up here on the top boundary line, and for a cosine function, I'm going to curve down through the midline, down to that bottom line, curve back up through the midline again, and end back where I started, in this case on the top line. So I'm going to do the best that I can to connect these, and it's probably not going to be too pretty, because I'm doing this with a little trackpad mouse on a laptop right now. Well, so good, or so far so good, not too terrible. Not my best, but then again, not my worst. There you have it. There is our function. Let's do one more a little bit quicker. Here we have -2 sine of 4 pi x minus 5. Again, if you need to pause, don't hesitate to do so. My amplitude is 2. I realize this is a -2 right here, but amplitude is always positive, so I don't care about that negative sign. That negative sign just tells me that my graph got flipped upside down. The period is going to be 1/2. Well, that comes from the formula 2 pi over b. 2 pi over my b value here, which is 4 pi. So 2 pi over 4 pi, pi's knock each other out. That's supposed to be a slash indicating that it got knocked out. And then 2 over 4 reduces to 1/2. That then gives me my interval, because 1/4 of 1/2, or 1/2 divided by 4, gives me 1/8. And lastly, I see a -5 here, so that means I shift down 5 units. That tells me my midline. So here's the basic framework for my graph. Again, I'm going to start at 0, which means I end at 1/2 on the x-axis. My interval is counting up by 1/8, so I have 1/8, 2/8, 3/8, 4/8. Obviously, some of these reduce. My midline is at -5. That's from the d value. The amplitude was 2, so from the midline I go up 2 units and I go down 2 units. Now, since we know that this was a sine function and it was negative, we know that it's going to have to start off on the midline, which means it also ends on the midline. And since it's negative, it's going to come down towards the bottom line first before it bounces back up. So I can plot my critical points here. And these points just kind of give me a nice little framework to try and follow. Again, I'm going to try to do this the best I can with the trackpad. It's probably not going to be so pretty. Your goal when you guys do this, oh gosh, when you guys do this on homework and tests, make yours look better than that. All right, so that's how we graph them with translations. Next up, let's take a graph and write the equation for it. I would suggest at this point pausing the screen and making sure you can paraphrase each one of these, if I were you. So in writing the equation, we have to first distinguish, is it a sine or cosine? We don't know how to do phase changes yet, or horizontal shifts, so we can't really argue that it could be both yet, even though that is definitely a possibility. We're going to draw a box around one of the cycles. This is going to help us determine the max, the min, the midline, the amplitude, and where it starts and stops. Then we're going to find the midline. That's going to give us our d value. We'll figure out the amplitude, the a value, and then the last part, our b value, we're going to have to first figure out the period and then use that to get our b value. So that's going to be a little bit more labor intensive, but not too terribly difficult. So let's take a look at an example. Here I have some sort of a curve. I don't know exactly what type of curve this is. First thing I'm going to do is draw a box around one complete cycle. So you'll notice that I'm starting, let me get the pretty pens, starting here. Then we go up to the max, down to the min, and we end the same place that we start. Well, just by looking at this, I forgot one of the points. Silly me. Just by looking at this, I'm kind of able to tell that my midline is right about here, right where those 3 smileys are. And if I really wanted to, I could prove that, right? Because halfway between +2 and -4 would be at -1. So I have a d value here, give me -1. My a value, the a value is from the midline, how far up do I go? So if I go from -1 all the way up to 2, or from -1 all the way down to -4, I've traveled 3 steps. So my amplitude here is 3. Next up is the b value. So the b value is going to be kind of tough. The b tells us, or helps us find the period. So remember the equation is, period is going to equal 2 pi over b. Well, I know that the period in this case is going to be pi, because I started at 0 and I end over here at pi. That's going to equal 2 pi divided by something. So I'll just leave that as a variable of b. Pi equals 2 pi divided by some variable b. Well, essentially, I just need to find a way to cancel out that 2. So my b value in this case must be 2, because 2 pi divided by 2 would just give me a plain old pi. Well, now that I have my a, b, and d values, I have to distinguish, is this a sine or a cosine? I'm starting off on the midline here, so that's a dead giveaway. We have a sine curve. So the equation for this bad boy is going to be y equals positive 3, because we're going up in the positive direction from that midline, positive 3 sine of 2x plus, oops, my bad, minus, that's what I meant, 1. So just by taking a look at the graph and figuring out those key pieces of info, we are able to build each one of these little variables into our equation. As always, if you have any questions or if something does not make sense, please do not hesitate to ask for some assistance. I'll be available through email or before school just about every single day. Come on in and get some help if needed.